video we are going to talk about the integration. So let us say that we have the function y equal x to the power n, so such that n is not 0 and n is not -1. So now let us just keep it simple, and then the integral of this function x to the power n dx, so that is the main rule, that is equal to x to the power n plus 1. So we add 1 to the exponent and then we divide by the new power, so plus, and we add a constant. Now we will see why we add a constant when we integrate. So let us say that so assume that we have y equal to x squared, and then the derivative of this function, so dy by dx, so that is equal to 2x. So and now if we integrate this function, which is 2x, then we will get, let us see what we get. So if we integrate 2x with respect to x, then we get, so we apply this rule, 2x, then here the exponent is 1, then that means we are going to add 1 and then we divide by the new power, which is also 1 plus 1. So and then here we get x squared. Let us say that here here I'm not going to add a constant now. Let us see why so this is 1, why we must add a constant here in this function. So that means so the integration is just so it's getting us back to our original function f of x when we integrate. So and then let us say we have y equal to x squared plus 1, and now here the derivative of this function, so dy by dx, that is also equal to 2x, right? Because the derivative is 1 is 0. So and if we integrate the resultant derivative here, 2x, so the integral of 2x with respect to x, so the derivative, so 2x dx is equal again, so we will get the same answer. But now notice that the original function here is x squared plus 1, and then here after we integrate, so then we get x squared, but then that means we didn't get the original function after we integrate, and this is why, so whenever we integrate we always add a constant, which we do not know. Here the constant represent 1, right? So and this is why always when we integrate we add a constant, as you see here in the main rule, this one. So this is the definition of integral for polynomials. And of course, if we integrate some other functions like exponential functions or logarithmic functions or trigonometric functions, then we will have different rules. So let us take an example. Now here we define the main rule, and then we understood why we add a constant, because when we integrate then we need to get back to the original function. So in general, before we even take an example, so let us say we have a function y equal to f of x. So and then if we integrate this function, then that will be equal to a function f of x plus a constant. So it's clear here. So this is the integral of a function, then we get a function plus a constant, such that, so when so then that means here f prime of f of x, that means when we differentiate this function, then we get the integral function here, which is 2x. So that means the derivative of capital F is equal to f of x. So this is a kind of fundamental thing that now take example of integrating polynomials. So let us say that we would like to integrate x to the power 3 plus radical x plus 1 over radical x dx. So here we just apply this rule. So we add 1 and we divide by the new power. But now here, in this case, we can rewrite this integral in the standard form. That means here we have x cubed plus, so this is x to the power half, and then here we would have plus x to the power negative half, because we can bring this up, then we get negative half, so dx. Now we can apply our rule. So the rule says we add 1, now we get 4, and we divide by the new power, plus, so we add 1, then we get so we get 3 over 2, and then so we divide by the new power. This is equivalent to multiplying by 2 over 3, plus here x, we add 1, then we get half, and we divide by the new power. This is equivalent to multiplying by 2 plus the constant. So you can do it step by step or just do it directly in this way. So this is the first example. So let us take a second example. So let us say another example. Example 2. So if you would like to integrate, for example, 2 plus x times x or 1 minus x, for example, dx. So now we need to write it in a standard form of like the standard polynomial form. So in this case we need to multiply. So we distribute, we multiply 2 by 1 and we multiply 2 by negative x. Then we multiply x by 1 and we multiply x by negative x. So that means this integral is equal, can be written in this form. So here we get 2 when we multiply 2 by 1, minus here we get negative 2x when we multiply 2 by negative x, and then we multiply x by 1, we get x, and we multiply x by negative x, we get negative x squared dx. So now we can simplify. Here we have 2, and then here we would have, so negative 2x and x, we would have negative x and then negative x squared dx. So now the integral of a constant, let us say, before we do the integral, so the integral of any constant a, let us call it a, dx, that will be equal to ax plus a constant in general. Now we can see why. So because, so this integral a, so it can be written as x to the power 0, because x to the power 0 is 1 dx, right? And then that will be equal to a x to the power 0 plus 1 divided by 0 plus 1, which is a new power, plus a constant. And here that will be equal to ax plus a constant. So, and now here this means the integral of 2 will be 2x. So our integral, we can write it here again. So we would like to integrate 2 minus x squared dx. So here that will be equal to, so this is 2x minus, here we add 1, that means we get x to the power 2, 1 plus 1, and we divide immediately by the new power, minus, here we also also add 1, then we get x to the power 3, then we divide by the new power here, which is 3, and then plus a constant. So this is here, it is our final answer. So now let us take another form, another example similar to this one. So another example, let us say we would like to integrate 1 plus x squared dx. So in this case we need to expand. Here we multiplied the two parentheses, but here we can expand. So we can say this is equal to integral of 1 plus 2x plus x squared dx. So, and then here, so we will get, the integral of constant 1 is just a constant times x. So we get x plus, so here we have 2x, then we add 1 to the exponent, which is 1 plus 1 is 2, and we divide by the new exponent. So plus, here we also add 1, then we get 3, and we divide by the new exponent plus a constant. So those would cancel out, and finally we would get x plus x squared plus third x cubed plus a constant. So and now let us just maybe do common mistakes that usually the students do when they integrate before we go further. For example, in the exam or in their assignment, they write integral x squared equal to equal to x cubed plus 3 divided by 3 plus constant. That is wrong. Why? Because here we need dx. So here we need dx. And then they also do this. So they said integral of 1 minus 2x plus x, any exponent dx. That is also not a good way of writing this integral, because we need two parentheses. So here the correct form, and the result is correct, but then the integral is not correct. Here we need to write it in the correct way. So we say integral x squared dx, and then here we also need to bracket, so or parentheses, so we say 1 minus 2x plus x cubed, and then we close it, and then we say dx, and those now are okay. So this is the standard form of writing the integrals. So we can continue and taking simple examples, and then later on we will solve, of course, more complex examples, and we will have many exercises. So, but now let us close our video with this kind of integral. Whenever you have this integral of, let us say, a plus bx, for example, to the power n dx. Let us say we have this integral in this form, and we would like to integrate. That is general. The rule says this is directly, so we will of course understand why. So this is directly is equal to a plus bx to the power n plus 1. So here similarly, so we just take, we first make sure this is linear. That means we don't have squared here. This is the first thing. So, and then we just add 1, and we divide by the new power, which is n plus 1. And then again here we say this is times here. So this is divided by 1, or sorry, multiplied by 1, or equivalent to say also divided by the derivative of this function here. So the derivative of this function, we can write it in this form. So the derivative of a plus bx here, so plus a constant. So that means this will be a plus b x to the power n plus 1 divided by, the derivative of a constant, which is a here is 0, and the derivative of bx which is b only. Then that means here we would have b times n plus 1, then plus a constant. So we will understand why in the next video. This is can be done by using the integration by substitution. So but now let us take just one example, and then in the next video we will understand how why this is equal to this. So let us say we have example. So let us say we have 1 plus, just let us keep it simple, x to the power 10 dx. So in this case here, this is equal to, we just apply the rule. So first we make sure that is linear. That means we don't have squared here or cubed or any higher order. So and then in this case we say 1 plus x to the power, so we just add 1, then that will be 11, then divided by 11, which is a new power. And now here we also need to multiply by the derivative of what is inside here, so whatever it is. So if we would like to do it step by step, then say we need to say this is times 1 divided by the derivative, which is d by dx of 1 plus x, so plus a constant. Of course the derivative of 1 is 0 and the derivative of x is 1, so that means we don't need anything here. So we can directly say that, so our answer is, so we have 1 plus x to the power 11, then just divided by 11 plus c. Okay, so how do we make sure that the integral of this function is this new function? So we can simply, for example, let us take this. If we take the derivative of this, here in our previous explanation, so we said that if you have an integral of a function f of x with respect to x, so dx, so if you have a function, new function, f of x plus a constant, how do you make sure we are correct? Then after taking the derivative of the resultant function, which is f prime of x, then that must be equal to f of x, so the integrand function, which is the original function. So in this case, if we would like to test, if we take the derivative of this function, so the derivative means d by dx for this function, 1 plus x to the power 11 divided by 11, then here say plus a constant, or no, that is not needed because it's already here, there. So if we take the derivative of this function, then what we get? So the derivative, we know that whenever you have, let us say you have y equal to x to the power n, then y prime, which is the derivative, will be n x to the power n minus 1. That means we multiply the exponent by the coefficient of x and we subtract 1, right? So we do here the same, but then that is different. So because here we need to, in this case we need to multiply by what is by the derivative of what is inside here. So that means we get 11. Then we multiply this here, we get 11, 1 plus x, so 11 minus 1 is 10, and we don't forget here we already have 11, and then this is times the derivative of what is inside, so this is times the derivative of what is inside the parentheses. So this is again, so the derivative of 1 is 0 and the derivative of x of 1, so here similar to multiply by, and then those would cancel out, right? So we only get 1 plus x to the power 10. So that means this is our f of x, right? The small f of x. This is the function that here we integrated. So that means that is is correct here. So thank you so much for watching the videos, and we will just continue reviewing the integration in the coming videos. And if you like this video, so please make sure that you subscribe to the channel